Many developers reach a point in their career where something strange starts to happen. You can build features, ship APIs, write tests, and review PRs. But the moment someone starts talking about infrastructure, your brain just switches off. Suddenly, people are saying things like, we need a private endpoint between the gateway and the origin. Cloudflare can't reach the back end. We'll terminate TLS at the edge and forward internally. And you're sitting there thinking, I write code. Where did all these boxes come from? If this sounds familiar, you're not alone. This video is for developers who build software but feel lost when the conversation moves to systems architecture. And this matters more than ever right now because AI has changed the game. AI can write code, generate tests, scaffold entire applications. But it doesn't understand your system. It doesn't know where the requests actually flow, where they break in production, or what should be exposed and what absolutely shouldn't. The developers who stand out now are the ones who understand that, not just code, systems. I'm a principal software engineer at one of the largest US payment processors. I spend my time working on real production systems and understanding the flow of requests across multiple services. And I've been exactly where you are. I could build features, I could ship code, I could pass reviews, but when the conversation moved to networking, gateways, or edge infrastructure, it felt like guesswork. What changed everything for me was this: follow the request. Once you can trace a request through a system step by step, all those boxes, they stop being abstract and start making sense. And that's exactly what I'm going to show you in this video. By the end of this video, you'll understand the one mental model that makes infrastructure click, how requests actually move through modern systems, and how to start learning architecture in a way that will actually stick. Here's the single most important idea in this entire video. Follow the request. Every system becomes understandable when you ask two questions at every step. Where does the request go next? And why is it allowed to go there? Because every system is really a series of trust boundaries. That's the entire game. If you can answer those two questions at every hop, you'll understand the system, not just the code, but how it actually works in production. Because infrastructure isn't a collection of random services, it's a path. A request moves from one component to another, step by step. And at each step, two things happen. It's being routed somewhere, and it's being allowed or denied. Once you start thinking this way, infrastructure stops being abstract. You're no longer looking at boxes, you're tracing a path. Let's follow a request. Start at the very beginning. This request could come from anywhere. A browser, a mobile app, an API. At this point, nothing can be trusted. Anyone on the internet can send a request to your system. Before your application does anything, something critical happens. DNS, a domain name server, translates api.example.com into an IP address. But here's the key point. That IP address doesn't point directly to your app. It usually points to your edge provider. That's a service sitting at the front of your system that receives internet traffic before your backend does. Examples of edge providers include Cloudflare, Fastly, or Amazon CloudFront. If your DNS is wrong, your entire system is down because even if your application is perfectly healthy, no one can actually reach it. The request now hits the edge, the outermost public-facing layer of your system. This is where most systems make their first real decision. Does this request even get allowed in? At this layer, you typically have TLS termination, web application firewall rules, bot detection, and DDoS protection. TLS termination means this is the point where HTTPS traffic is decrypted so the system can inspect the request and decide what to do with it. That matters because if your traffic cannot be inspected, it cannot be properly filtered, protected, or routed. This is your first trust boundary, a point where traffic is moving from one level of trust to another, and a decision has to be made whether it should continue. You're moving from the open internet into controlled infrastructure. Most malicious traffic should never get past this point. If the request is allowed, the edge forwards it to your backend. From the edge's perspective, the destination is called the origin. Important detail, origin does not mean your app. It just means that the next place the request is sent to. That could be a load balancer, an API gateway, a web application. If you see an error like origin unreachable, it means the edge tried to connect and failed. The request never made it past the edge. Before your code runs, there's usually one more decision point. A load balancer or reverse proxy receives the request. Its job is simple. Figure out where the request should go. It decides which instance handles it, whether that instance is healthy, whether traffic should be rerouted somewhere else. An instance just means one running copy of your application. If you have multiple servers or containers running the same API, each one is an instance. This is where routing rules, headers, and health checks come into play. Only now has the request been routed to a specific instance of your application. This is where controllers run, middleware executes, business logic happens. But your application isn't the whole system. It's just one more step in the path. Once your code runs, it starts making its own requests to other systems, to databases, to caches, to queues, to other third-party APIs. And these should almost always be private. If your database is publicly accessible, that's a serious problem. This is another trust boundary. And it's important because the internal system often holds the most sensitive data and capabilities. Even if a request has made it into your application, that does not mean it should be allowed to reach everything else freely. Good systems limit access at every layer. At every single step, the same two questions apply. Where does the request go next, and why is it allowed to go there? We ask these questions at the edge, at the origin, at the load balancer, inside your own system. Every hop is a movement and a decision. If you can trace that path, step by step, and understand those decisions, you're no longer guessing, you actually understand the system. Infrastructure feels confusing because people describe the system out of order. They drop you in the middle of a system and say things like, we need a private endpoint between the gateway and the backend. But you never saw how the request got there. So you're left trying to reason about a system without a path. You don't know where the request started, where TLS terminated, which components are public and which are private. Then those conversations just sound like noise. But once you follow the request, everything changes. That same sentence becomes something you can reason about. You start thinking, where is the gateway in this request path? What is it allowed to talk to? Why does that connection need to be private? You're no longer guessing, you're tracing the request. And that changes the kind of questions that you ask. Instead of memorizing terms, you ask, where does TLS terminate? Is that component public or private? What is filtering this traffic? What happens if it fails? Those are the questions that engineers ask when they understand the system. Because you're not thinking in terms of components, You're thinking in terms of requests, paths, and trust boundaries. And once you can do that, infrastructure stops being confusing. If you've been feeling lost in infrastructure discussions, you're not behind. You were just missing the right mental model. Start simple. Follow the request. At every hop, ask, where does it go next? And why is it allowed to go there? That's how infrastructure starts to make sense. And that's how you become the kind of developer who understands systems, not just code. If this has helped, consider subscribing.